Today's goal is to determine whether functions are even, odd, or neither. So we've noted in this unit that functions with odd degree have this shape if they have a positive leading coefficient, or this shape if they have a negative leading coefficient. Functions with an even degree have this shape or this shape, depending on if they have a positive or a negative leading coefficient. But we're not talking about just the degree, we're talking about if the entire function is considered even, odd, or neither. So these words even, odd, or neither we're using in different contexts, depending on if we're just talking about what's the highest power of x, or if we're talking about the entire function. In order to decide if a function is even, odd, or neither, we need some vocab words. So let's talk about opposites. Two numbers are opposites if they add up to 0. So for example, 2/9 and -2/9 are opposites because they add up to 0, as are -0.148 and positive 0.148. Opposites are not to be confused with reciprocals, such as 2/3 and 3/2. Or in geometry, you talk a lot about opposite reciprocals, such as 2/3 and -3/2. So opposite just means they add up to 0. Okay, now we're ready to talk definitions. A function is even if opposite x values produce the same y values. So opposite x values produce the exact same y values. So for example, f of x is 3x squared, has the points f of 1 is 3 times 1 squared, which is 3, and f of -1 is 3 times -1 squared, which is still 3. This is true for any x value, whether you're substituting a 5, 7, 143.2, 898, whatever. And then a function would be odd if opposite x values produce opposite y values. So for example, g of x is 3x to the 5th has the point, if you substitute in 2, you get 3 times 2 to the 5th. 2 to the 5th is 32, so 3 times 32 gives you 96. And if you substitute -2, you get 3 times -2 to the 5th. That's 3 times -32, which is -96. So we have opposite x values, 2 and -2, they're opposites because they add up to 0, produce opposite y values. One is positive, one is negative, but they have the same magnitude. We say a function is neither even nor odd if you can put in opposite x values and you're not always getting consistently opposite y values or consistently the same y values. So let's take a look at some examples here. Example 1, determine if it appears to be even, odd, or neither. So this isn't a definite proof, we're just giving some evidence. So let's take a look at opposite x values. -90 and +90 are opposites, and we see we're getting the same y value, whether you put in positive or -90. -180 and 180 are opposite x values, and again, you're getting the same y value, whether you put in positive 180 degrees or negative 180 degrees. So this looks like opposite x values produce the same y values. So even though we have no idea at this point in the year what cosine function looks like or really much about it, we can conclude it appears that g of x is even. It's an even function, not that it has an even degree. It's not a polynomial, but it appears to be an even function. Okay, let's take a look at another example. Again, determine whether the function appears to be. This isn't a definite proof. We're just giving some evidence. Let's take a look at some coordinate pairs. This looks like the point 2, -30, about. And this appears to be the point approximately 2, 0. So we have opposite x values, 2 and -2, But negative 30 and 0, they're not the same number, and they're not opposite numbers. So we can say we see that this function, the function as a whole, is neither even nor odd, since the opposite x values 2 and negative 2 produced y values. Let's go in order. 2 produced the y value negative 30, and negative 2 produced the y value 0. So negative 30 and 0 respectively, meaning in the same order that I'm giving the x values, I'm giving their corresponding y values. So we see that this function is neither even nor odd, since the opposite x values, 2 and negative 2, produce y values negative 30 and 0 respectively, which are neither the same nor are opposites. Okay, last example of the day. This is the good stuff. Here we're going to actually prove that for absolutely every single x value, we'll be able to tell if putting in an opposite x value, so not just trying 1 and 2 and 14.2 and 3/8, but every single x value, whether it's going to produce a y value that's opposite, the same, or neither. So this all hinges on what happens if you put in an opposite x value. So let's put in negative x. You get 5 times negative x cubed minus 4 times negative x plus 1. So this is 5 times negative x times negative x times negative x. I'm just expanding this negative x cubed bit. Plus 4x, because if you're multiplying negative 4 by negative x, plus 1. So we get 5 times, this would be negative 1x cubed if we're multiplying negative x times negative x times negative x, plus 4x plus 1. So we get negative 5x cubed plus 4x plus 1. Okay, so these are the y values that are produced by inputting or substituting opposite x values, right? This is just some x here, and this is the opposite of whatever that x value is. So the question is, are these values right here the same as these y values? Well, no, they're not the same, because you have a negative 5x cubed here and a positive 5x cubed here. So we know right away the function is not even. You're not getting the exact same y values. Well, are you getting opposite y values? Opposite y values would mean you're taking the entire function f of x and you're multiplying the whole function by negative 1. So let's take these y values, the original y values, 5x cubed minus 4x plus 1, and multiply or distribute that negative sign. You get negative 5x cubed plus 4x minus 1. But again, these aren't exactly the same as what we got when we put in an opposite x, because here we got a positive 1, here we got a negative 1. So we conclude that the function f of x is neither even nor odd, even though it has an odd degree, a degree of 3, right? The function as an entirety is neither even nor odd, since inputting opposite inputs, right, negative x, produced y values. Here's what we got, negative 5x cubed plus 4x plus 1, which are not the same as f of x. Our original function had positive 5x cubed. Here we're getting negative 5x cubed, nor are opposite. It's not the same thing as multiplying the original function by -1, because if we did that, we would get a -1 here instead of getting a constant of +1. So the function as a whole doesn't match the opposite y values. It does not match the same y values. So the function as a whole is neither even nor odd.